For those of you guys just joining us, we're looking at the standard form of ellipses. Try example that we were working on in the back of our homework spiral when class started. What do we know about the major? Looks awfully horizontal to me, but Sam's like, not even does it look horizontal. They told us exactly what's going on with him. The major axis has a length of 6. So what did you make 6? Wrong. But for 6, you were able to make the A, and the A was the 3, right? Because, does this say the major radius? No, it says the major axis. Now, they don't call it diameter because it's not really a diameter. I put my radius in little quotes yesterday a lot. The axis is the entire from the far left to the far right. And this one, because it's horizontal, it's the entire length all the way across your ellipse. So if the whole thing is 6, then A has to be 3. Does our picture agree? Boop. Yep, it does. But what's the problem? I have my H, I have my K, I have my A, but now I need my So what did I tell you guys to go look at? Or maybe what did you figure out on your own? What other formula is there? C squared equals. So if we know that A is 3, wouldn't that be 9? And if we know C is what? It's the one thing that's not labeled in the picture, but it's still there because C is like P, kind of. C is like P, but P was from the vertex of a parabola to the focus. So it's similar in that we use it, but it's different in that it doesn't measure from the outsides of the shape. It measures from the inside. So C says, how far is the focus from the center? So C is equal to, Kyle, you said something like the distance between 2 and 4 and 4 and 2, right? What is that distance? Got him. Is that the same thing as the distance between 2 and 0 or 0 and 2? Yep. So either way, it should be C. And either way, we can say 2 squared is 4. And then we can subtract, and that's negative 5. Divide by a negative, that's positive 5. So B is equal to positive or negative or both? Positive, because it's just a measurement. Ooh, I did have it hidden. So let's put all these clues together. So now we can go ahead and say, wait, who comes first? A, which is 3 squared. And then who's on top? X minus 2 because of the center, right? What's the sign that goes in between for ellipses? Ellipses? Plus, like a circle, x minus h squared plus y minus k squared. Who is my y minus k? Who's my b? Rad 5 squared is b squared in the formula, and that equals 1. Now, yesterday, at the end of yesterday, do you guys remember I was doing the example, and I said, oh, it could look like this, or it could look like that, or it could look like this. Ooh. And I said maybe you should keep an eye open in the book to see what they want. So here, let's keep an eye open in the book and see what they want. What do they want as far as standard form? It's coming. Oh, chapter 9. That was so long ago. Hey, tutoring hours. What are regular pre-cal starting on today? Binomial theorem. What? Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. How to do the term, how to jump to a spot. Fun things, fun things. You could be tutoring them. All right, let's see. The book starts off with, after vocab, match pictures, ellipses with equations. And the equations look to be awfully standard formish. Awfully standard formish. Is it better if I turn that off? That doesn't really make a difference. Okay. Then we have pictures, they want equations, then we have clues, and then we have more pictures and more clues, and then we have really, really messed up ones. Oh. That's a struggle. Oh, no, these ones aren't very messed up. These ones are awfully nice. Okay. So let's go ahead and peek really quickly at the back of the book, somewhere around the 10s, 20s. What kinds of answers? Some of you have already looked this up and some of you haven't. So it's okay. We'll do it together as a class real fast. In chapter 10, in section 3, ellipses, what kinds of equations do they want? Looking in the 10s and the 20s. Guys, where would they have stopped? Yeah. So technically, couldn't we come back here and say, okay, well, that was all well and good, like good job and all, But couldn't we take these away and say, actually, they wouldn't have wanted us to keep going? I mean, they might give us something gross like this. But even though they might give us something gross like this, to be honest, they would actually say, at least as far as the back of the book is concerned, that this is the answer. Ba-doop. So is this one bad? No, it's actually great. But is this one what we would be answering? No, that's okay. When they say standard form, we stop back here. I mean, x minus 0 is x squared. We should be able to do that. Simplifying the complex fraction, over 9/4 is times 4/9. But they say you can stop there. So if they say you can stop there, then where do we stop over here? Are we done? Can we stop? Let's look at the back of the book. Do they have little squares written? Oh, no. What have they done in all the denominators? Ah. They've answered the square. Yeah. Complete the squares like binomials. But yeah, they did the square. So therefore, what would our final answer have been? We can leave it like that. We can put it over that. We can leave it like this, and we can put it over this. How are we doing? Give me a thumbs up if you're like, nah, I think I get it. Give me a thumbs middle if you're like, yeah, I think it's possible. I just don't get it yet. Give me a thumbs down if you're like, no way, Jose. Ah, okay. So let's keep playing. Oh, come on. You guys just saw me do this in the book, didn't you? Didn't we see a section? Oh, okay, there are nice ones. There are nice ones. There are nice ones written in the form that we like. But what else are there? Okay, so we're going to practice one. But hold on. Before you guys write down the nasty equation, or as you write it down, you should be reading the directions like we always do. True? You should be reading the directions as we always do. And what do the directions say that we need to identify? Yeah, all the important things, right? All the important things? Eccentricity. Oh. Oh. We'll get to it in a second. Let's figure out the center of vertices foci first. And then sketch. And then we'll talk about eccentricity because I think he's on the next page. All right. Which standard form do we want? Who goes first? Wait, look at your yellow box. Who always goes first? Yeah. So can't we just, I mean, we don't know if he has an A or a B. We don't know if he's the bigger one or the smaller one. But we can still do the like, okay, well, we want to do something like this and something like this. And then we want them divided by, I don't know, something squared over something squared. I mean, it's going to just kind of happen. We can't really like make it whatever we want it to be. That's a question mark that's kind of. So, what do you guys think? Oh, yeah, have we not made it back into our notes? Lo siento, back into your notes, please. Thank you, thank you. Thanks, Gavin. Good question. Good question. What do you guys think we should do? You've done enough algebraic stuff with me. You see where you want it to go. You see where you want it to head. Any ideas how to get there? What do you guys think about Kyle's advice? Would it be a smart idea to try grouping things by their terms? Now, is segregation always right? No, but is it sometimes useful? In math, for sure.
In life.
Can still be useful in life. If any of you guys like, have you ever done like family hangouts and there's like the kids table and then like the guys are over here doing one thing and the ladies are doing like, sometimes it just naturally happens. It's not like it's evil. Like it's okay for kids to hang out with kids and adults to hang out with adults and gals to hang out with gals and guys to hang out with guys. Now, should you do that all the time? It's probably not healthy if it's that you're only hanging out with kids or adults are only hanging out with adults or guys are only hanging out with guys, but it can be quite useful, helpful, encouraging, etc. But mathematically speaking, there's no way we're going to get even close to this unless we try to start grouping things. So Kyle said the x squared with the x, and I totally agree. Why didn't he say with the x's number term? I mean, that's an x term. I mean, it's x squared, but in terms of x, in terms of x, in terms of... let's just leave a space and be like, I mean, don't we usually have 3 things for a trinomial? Interesting. Well, and then we had the 4y squared. and we have the 40y, and then we... Well, why is it? Because it's simplified. Didn't he have a number? If we were to multiply this out, wouldn't this have a trinomial and that would have a trinomial, but both of them would have constants? And what would happen to their constants? They would have been combined. So how do we split up 37? We don't. We say, you know what, it's too complicated to be like, what's 37? I don't know, 1 plus 36 or 2 plus 35 or 3 plus 34, or we could split it up tons of different ways, and that's just the whole numbers. What about fractions? Ah! So instead we say, move the 37. We'll figure it out. We'll figure it out. We'll figure it out. Now, I want to figure out what goes here, but before I figure out what goes here, question, should we have an a inside? Should we have a coefficient inside next to the x and next to the y? Nope. So who doesn't belong? So I'm going to pull him out. I still have a blank, though, because I think there's supposed to be a third term, a trinomial, a constant. There's supposed to be one extra piece to get this dude, because we don't kill puppies in this class. No, we don't. We would know this should not just have 2 pieces that come out, but 3. Well, technically 4, but 2 combined. Yeah.
So, well, everything is still on the one side, right?
Yep. Well, I moved the 37 because I'm like, I don't know how to split. Besides him, everything's on one side. Now, guess what I have to do for the y terms also? I have to pull out the 4. I have the y squared plus the 10y. He needs a constant. Why am I doing 2 blanks over here on the... Twice, because I have 2 different terms. It's not like a parabola where I only had 1 squared. Now I have 2 squareds. But it's okay, because we reviewed complete the square last section. How do you complete the square? Take the middle. You have to say he had to come from 2 equal pieces. So 6x had to come from 3x, 3x, and 3 and 3 had to square to be 9. Or if you want to memorize a little thingamabob, you can take the middle coefficient, which is -6. You can cut it in half, and then you can square it, and then you can put it there. Exactly. So Robbie already went ahead and said, which I can follow the pattern. The pattern is 5 squared is 25. If we add 34, that's going to be a negative number. Ah! Can we have a negative number for a circle?
9.
But wait a minute, what did you guys forget? It wasn't 25, it was 100.
Oh, and it wasn't 9.
And it wasn't 9, it was 81. Woo-hoo-hoo. Why? Because I added a 25 here, but what's the 25 being multiplied by? 4. And I added a 9 here, but what's the 9 being multiplied by? The 81. Is it dangerous sometimes if our focus gets too narrow and we forget the big picture? I don't even have to say it anymore. Thanks, guys. So what's 181 minus 37? 144. Ooh, that's nice.
That's very beautiful.
Because all we have to do is stuff, right? Oh, to divide? What? Oh, because what's your standard form supposed to have? A 1. This isn't a circle. We're not in Kansas anymore. Ooh, another old movie illustration. What?
By the way, you said a reference to High School Musical yesterday. It was actually Hercules.
Yeah, it was. I know. After I said it, I was like, that's so sad. It was so sad. It's okay. Get your head in the game. Now that's High School Musical. Or the, oh, what's the one with them in the junkyard and it's like the big kids and the little kids? Something about boys. You know what I'm talking about from the first one? The boys are back. Thank you, Angie. There we go. Which, well, one came back and then one left. Anyway, we have what? We have 9x minus 3 squared. We have 4y plus 5 squared. Because we're awesome. We can factor, right?
Yeah, we can.
Yeah, we can. But what's the struggle? Where's our A and where's our B? But it's okay. We're not done yet. We're not done yet. This isn't a circle. It's an ellipse. So if it's an ellipse, we need a 1. We don't need a 144. And the only way to get 1 is to subtract 143. That doesn't get us any closer. We're not subtracting. We're going to divide.
And And then we're going to give
Oh my goodness, so 12 and 12? Oh, there's a 9 on top and there's a 4 on top. I wonder if 9 goes into 144. The answer is yes, and it's 16 times. How'd I do that? Because I'm a genius and it popped into my head? Nope. I don't mind doing a little bit of work in my head. 14 one time, 54, and 6 times. If your brains just pop up with a 16, good job. I'm so proud of you. You're above me. But anyway, coming back. Well, not that any of us are necessarily above any other ones, right? It's just different life experiences, talents, abilities, age. Yeah, you already did it? I totally agree. Standard form check. Once we have standard form check, what can we do? Yeah, we can draw it, we can identify it, we can label stuff, because aren't we supposed to be finding things anyway? So cool, kids, we need a center, we need a vertices. Ooh, figure that out in a second. Foci, and then a picture. Let's start with a picture. Where is this guy? Do you see if it's 3, -5? Maybe having all 4 quadrants equally spaced is not a very smart idea. Why don't we do something more like that? Does that sound better? Because I can do like a 1 and a 2 and a 3, and I can do a 4 and a 5? No, 3. 1 and a 2 and a 3 and a 4 and a 5. That would be a center of 3, -5, right, guys? Ah. So we have to look for h minus h and k minus -5. Cool. We have other stuff to label, but we also have a picture to make. Guys, how do we do a picture with an ellipse? We have an HK. Now we also need A's and B's. How do we use the A's and B's? If I know A is 6 and B is 4, and the 4 is underneath the X, what should I be doing horizontally? Should I be going horizontally 4 one direction and 4 the other direction, as though I kind of had like a compass that I was extending and marking? Bloop, bloop, bloop. My B is 4. What's my A? Now, what's the kind of sad thing about how I drew my picture? 6. What does it look like if I put my 6 tick marks I did? It's really distorted. Hey, guess what else is really distorted?
Human nature.
Oh, we could go there. We could definitely go there. And yes, mine, yours, everyone's true. Brokenness shows up in many different forms. For some people, it's all inside, nobody sees, whitewashed tomb, great on the outside. For others, oh, I see your brokenness all over the place, but at least it's honest. My advice, always bring it into the light. It's a safer place to be than the dark. But coming back. Coming back, I meant like literally, what else graphs in a distorted way? Graphs. What else graphs in a distorted way? Why is he always distorted? If you're in Zoom standard. Because your screen is a rectangle and a 10 by 10 is a square. Oh. So doesn't he graph in a way everything's squished also, because the y's fit in as many tick marks have to be closer together than the x's? What's that Zoom? Back from the first week of school. That was forever ago. What was that Zoom? Makes everything all nice and even and didn't show you any distortion? Zoom square. Now, could I zoom square? I suppose I'd have to erase and do it all over again. So I'm not going to zoom square, but we get this distorted a little bit, right? Go ahead and label this as, because it's 6 tick marks, just realize they're squished together, so it looks more like a circle, when really it is to be an ellipse, right? Oh, I should have done my little. Okay. Question. What are my vertices? What's an ellipse? Oh, but they do have vertices. It's not a parabola. Yeah, Robbie's going like this, but technically, am I going to have him switch his hands to go like this instead? Yeah, the vertical axis is the major one. Vertices are only the major endpoints. So who's the major? 6. Here. How do we find those points? Hey, what's the x for all of these guys, including the center? 3. So just the y changes? Okay, so where do I go from -5 to get to one vertex? Up 6. So -5 plus 6 is just going to be 1. And what's -5 minus 6? Does this sound like we're doing this visually? Some of you guys that took pictures of a big old diagram, weren't there like actually in the books like diagrams that you could memorize as far as plugging in to find vertices and centers and foci? Yes, so this might be another place where you're like, nope, 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 nope. I don't like the visual thing. I'm going to go memorize stuff. Totally fine. I'm not judging. It might just be a little bit harder and take a little more time. But if that works for your brain, do it. Do it. Who are the foci? Where are the foci? Who are the foci? Where are the foci? Oh, so many questions. Poor little foci are having an identity crisis because no one knows who they are. Who are they? Where are they measured from? Is that a better question? The center. Good. So the foci are measured from the center. Headed what direction? On the major axis. So good. So we've gotten so far from the center on the major axis. Anything else? Why should I be waiting for a C? Oh, they're C-aways. Not only are they measured from the center, and they're measured on the major axis, they're measured C away. Now, hold on. What is the point of, oh, I don't have scissors. I mean, I do. I just have to walk back here. What is the point of the foci? Do you think the foci are always in the same place? Are they always in the same place, like a vertex is, or like a center is, as far as an ellipse? Or do they change? Why do they change? Based on the A and the B and the distortion? What do you mean, Kyle?
Whether it depends on how big the ellipse is, how small it is.
Okay, so what would happen if A equaled B?
It'd be a circle.
What? If A equaled B, it'd be a circle? Why?
The radius is
The radiuses would be the same. So what does that mean about the foci then, though? If A equals B, C would equal 0. So does not every ellipse have a focus? Wait a minute, you guys just said it wasn't an ellipse, it was a circle. Oh. So what's different about a circle versus an ellipse? A circle, how many radii do you need? Just one. An ellipse, how many radii do you need? And technically, the two aren't even just two. Isn't it more like a range? Because as we go around an ellipse, where's my stronger magnet? This one will work. As we go around an ellipse, the shortest distance is the minor radius. The longest distance is the major radius. Some poor person's necklace has been here all year. Not literally, just all semester. There we go. Okay. So what happens if, well, hold on, a circle. A circle, couldn't I just take this length and then a circle is just you go all the way around and it's one radius and we're good, right? Okay. That's like a compass. But an ellipse says there are two fixed points that can either be closer together, foci, or farther apart. If they're farther apart, what does that mean as far as our shape? If the focus is here, the focus is here. What's true about that ellipse? The closer the foci are to the vertex, the more elongated the ellipse. But, question, what if I put the foci closer together? Then what's going to happen? You guys see how there's more slack? Since there's more slack, what's going to happen? Is this a circle? No. Why isn't it a circle? Because it's always changing as I go around. But with my foci where they were, what ended up happening about or with the A and B? The smaller the foci, the closer the A and B. The bigger the foci, or the farther apart the foci, the larger the difference between A and B. And all of that can technically be in the formula c squared equals a squared minus b squared. You guys told me a circle which has absolutely no distortion would have A and B being equal, and so C being 0. But what if C was really tiny? Well, that means that these still must be really close. And if they're really close, well, then the major and minor aren't much different. But if C is a big number, if they're far apart, like way out here to the outer edge, if C is a big number, if they're farther apart, that must have been that the major was way different than the minor. And if the major is way different than the minor, well, yeah, the shape is going to look a lot more elliptical and a lot less circular. How do you make an ellipse? It's not like a circle. You have a set radius and you go all the way around. It's actually from foci with some sort of suspended distance. It's still the circular pattern, but it's actually built on foci, not centers. Centers are for circles, foci are for ellipses. Interesting. But anyway, all that to say, to get your foci, where are they? Are they here? Are they far away from the center? Are they here? Are they close in? Well, 6 is a lot different than 4, but let's see how different. We need to go ahead and plug into our formula that c squared is equal to 36 minus 16. Whoa, how am I doing that? A squared minus b squared. And so we end up with c squared equaling 20. Hey, does that have a perfect square root? Nope, but 4 is in there, which has a perfect square root, so I'm going to have 2 root 5. Now, 2 root 5 is how far I go from C along the major axis towards the vertices. So if I'm going, what's 2 root 5-ish? What's root 20-ish? It's more than 4, it's less than 5. It's more than 16 and less than 25. So it's 4 point something, something, something. 4 point something, something, something will get us somewhere around here. And somewhere around here, there are foci. He should be a little bit higher. But guys, I don't even necessarily need to show it perfectly on a graph. What I need to do is show it perfectly in an equation. So can't I do something like, hold on, how did we get the vertices from the center? What did we keep the same for the vertices? What did we keep the same for the vertices? The x. So guess I'm going to keep the same for the foci. The x also. But what do I need to change? The y's. And how do I change them? Well, I say start from where we were, which was -5, and add and subtract root 20. Dun, 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 dun. Woo! Find your c, and then you can go ahead and say, well, the same direction of the vertices, keep the x, add to the y. I'm going to do that, but I'm not adding the major axis length. I'm adding the c instead. Hold on. Who are we missing? Have you ever heard of someone being eccentric? Eccentricity. Eccentricity. Now here's something awkward. Ready? Eccentricity is going to be E equals. Oh, but we have any. Wait, I know, I'm sorry, Lo siento. This is not what I'm talking about in this context. I'm talking about eccentricity, and who is this eccentricity dude? Eccentricity, know how we were talking about foci and whether they were close or whether they were far, whether they were close to the center or far away from the center, and how that affected the, well, I just kept saying the distortion. It affected how circular versus how elliptical it looked. That's awkward. There's a word for that, and the word for that is eccentricity. The eccentricity of an ellipse. The ovalness of an ellipse. I know it's awkward. The ovalness. Ugh. How distorted it looks. C over A. Didn't we say something about C can equal 0? If C equals 0, what does that mean about my ellipse? What does it just become? The foci became so close that they ended up colliding at the center. There are no foci. If there are no foci, what shape do I have? A circle. So, what kind of eccentricity does a circle have? If C is 0, then E is 0. A circle has an eccentricity of 0. So the more circular it is, the closer to 0 it is. The more circular it is, the closer to 0 it is. The smaller the eccentricity. But hold on, what if C is as big as stinking possible? What if C, the foci, got pulled all the way out? If the foci got pulled all the way out, that circle got completely squished. It's actually fine now, super awkward. So a circle, no eccentricity, and a line would have an eccentricity of, your foci would be on your vertices. There wouldn't even be an ellipse because there would be no place to go because your whole string got up. That would be an eccentricity of 1 because C would equal A. If C equaled A, there is no ellipse because there's no slack in the line to draw. So eccentricity goes between 0 and 1. 0 is the circular side. 1 is the completely flat side. So we can say this is super circular. We can say 1 is super flat. But we don't like, oh, it's more circular, or oh, it's flatter. Instead, we just say, oh, the eccentricity is 2/3. Oh, okay, so it's more elliptical. The eccentricity is 1/5. Oh, it's more circular. The closer it is to 0, the more circular it is, and the closer it is to a flat line, the higher the eccentricity and the more oval, or the more elliptical. But all of that to say, we just put a number on it. So to put the number on it, it's like, okay, cool. For this guy, how eccentric is he? Who's your C? And who's your A? 3, careful, right? Because 6 is the whole thing, half that. Can someone go ahead and put 2√5/3 and get me a decimal answer? I want to see how elliptical this is. Is this more circular? Is it more elliptical? Is it halfway? Based on the major axis of 3 with the foci of 2rad5, what decimal would we get with 2rad5/3? Oh, Tony, you were right. I'm the last example. You should have corrected me, bud. Good job. Remember the last example was the major axis of 6, and then the A was 3. That eccentricity was going to be over 1. Over 1's impossible. Now try. Ooh. So if it's 0.745, is it closer to 0 or closer to 1? Closer to 1. So even though it looks circular, is it more circular? No. If we did a zoom squared, this guy should have been squished in because he's definitely very pronounced as an ellipse. All right. Whew. What did we do today? A lot. We talked about where an ellipse actually comes from foci being closer or farther as how eccentric it is, how circular or how flat. We talked about the standard forms. We talked about, completing the square twice. But basically, we brought you up to where you are ready to finish homework tonight for tomorrow so we can go over questions. Sound good? Oh, I saw that. Boys will be boys. Just be it safely and kindly. Not sure if that's where I was headed, but that's okay. E for effort. We just talk about football players. You want to talk about football players instead? All right, cool kids. Any questions about life? Any questions about math? Any questions about ellipses? Well, we're doing okay? I suppose. Just because we were able to finish early. However, only one donut hole each, and I will stand right here. Go. What? What's going on? Who's on first? Bye, guys. See you later. Who's going to share? Yeah, good job. Good job. stop recording. It's just going to be like weird coffee sounds. All right, you don't have a lot of time before your next class, though. Probably just half a cup. I don't want you guys going